ridiculous and complicated, but we as humans like to slap labels on things, and so we do that with objects that we find out there in space. Now, we'll never really understand everything that can be found out there, but today I'm going to teach you just a few things that you can understand and try to show you that they're not as impossible as they seem.
It's okay. Help us, I'll tell you what, sometimes this happens in speaking, and you just want to narrate over it, okay? Help us through when the technology is failing, just help us through what is supposed to happen, and we'll all giggle at the technology.
Well, first we were going to look at nebulae, but it doesn't look like it really works on it. It wants to work right now. It's a big file, so.
I tell you what, I am getting a kind of a glare. Brett, would you try to lower those what are those called?
Blinds.
Great technology, I love them. Blinds, thank you. Yeah, all the way, and the other one too, please.
That's pretty good.
Great, thank you.
I'll just go ahead and tell you about nebulae. Nebulae are all those really pretty cloud pictures that you see when you Google stars. They're not actually stars. What they are is they're big clouds of gas and dust in space that kind of pull together to create these beautiful images that we see. Nebulae is Latin for cloud, and that's what it looks like. So originally, nebulae was a name for any unknown astronomical object, like the Andromeda Galaxy was originally called the Andromeda Nebula because we didn't have any idea what it was. And it was so pretty and colorful, we just call it a nebulae, why not? Nebulae have different visibility at different wavelengths, that's why they vary so much in color. So we could either scan something in like ultraviolet, or we could scan it in like a X-ray, and it shows up in different colors. And so we try to find the visibility that works best on which screen. So if you were out in space, theoretically, looking at a nebulae, you wouldn't see the pictures that you see because those pictures are taken with a filter. It's really not cooperating. That's okay. I can't do this.
That's tough. That makes it tough. You know, here's a proposal. I don't know, the Prezi technology, so it's not like I can.
Try to make this screen smaller.
Yeah, there's an idea. Yeah, if you don't maximize it, does it help? So I'm wondering if there's a bandwidth that
Jose,
might.
you're a genius. Okay, sorry.
Oh, good.
It'll
Okay.
be okay now. Okay, so it's an interstellar cloud of dust, hydrogen, helium, and other ionized gases. Mostly it's hydrogen. That's like the element of the universe. It's a scientist's best friend because when they first look at an object in space, they try to identify how much hydrogen is in it and how the hydrogen is reacting with the other elements that are with it. Now, these two over here are called emission nebulae. The clouds are usually yellow because they have so much hydrogen in them, and that's the color that it gives off when it's burnt. The Carina Nebulae and the Omega Nebulae are two of the biggest, and you can see they look like big, beautiful colored clouds in the middle of space. The Cat's Eye Nebulae is a really, really special one. It's called a planetary nebulae, and they occur when the dust from multiple galaxies clumps together. So if there's a bunch of matter in this galaxy and there's a bunch of matter in this galaxy, and they gravitationally get pulled together, what happens is this crazy spinning amount of color. The first one is in an X-ray lens, and the second one is in an ultraviolet lens. So you can see how it changes color whenever you look at it through a different point. All right, then we have dark nebulae, and they're exactly what they sound like. They're dark, and you can't really see them unless you have a bright object behind them, illuminating them, but they still have that cloud formation to them. They don't exhibit visible radiation, which means we can't take a radiation lens and look at them because you won't see anything, you just see stars. You have to be able to look at them, usually through an ultraviolet lens with an object like a galaxy or star behind it that shows through. Post-nebulae. So after a nebula is formed, what happens? Does it just sit there forever? No. Nebulae will eventually become stars. They'll pull in all of this matter and crush it up together, and then stars are eventually formed from that. And then whatever's left over in the nebulae, it creates, like planets and moons and the asteroid belts, and that's how galaxies are formed. This is the Horsehead Nebula. It's an example of a dark nebula. You wouldn't be able to see it if it wasn't in such a bright part of the galaxy where you get all this radiation coming in behind it, and so it lights it up. Otherwise, it would just be a dark mass that you couldn't really see. These are the pillars of creation. Now, this is in the Eagle Nebulae, and it's actually right now forming stars. That's why we call it the pillars of creation, because it's the only nebula we know of right now that we can see it pulling in all this matter and processing it into a star. All right, supernova are one of my favorite things to study. It occurs when a high mass star reaches the end of its life, and it's actually a special type of nebula. What it is a supernova occurs when nuclear fusion in the core of a star stops and the star collapses. So in the middle of our star, there's all this heat and lava that we say is flowing around. It's actually nuclear fusion going on. It's so hot, we can't even measure how hot it is. That's how hot it is. And whenever that stops and it goes cold, the star starts pulling in all of this matter around it, and it condenses till it's a white dwarf, which is the smallest sun there can be. And so it's compressing all of this matter, and it will either reject the matter and just be a white dwarf, which is just like the size of our moon, just this little ball of rock floating in space, or the matter will come in and then expand out and suddenly explode. So that's how we get a supernova. All of these pictures that you see of the rings around the circle, that's when it's exploded. Synchrotron emission is really interesting because supernova, they don't emit any thermal radiation. They don't let off any heat at all. But if we use a special lens, we can see that there are electrons moving within it, and that's how we figure out where they are, because they're invisible to the eye. Historical supernova are known simply by the year they occurred, so supernova 185, supernova 1006, that's just the year that they happened to explode. But since 1985, the additional letter A is added to the end, so supernova 1907A. Kind of crooked, but I'm going to try and show you the process of a supernova. What you see right there, there's a little arrow pointing to this bright star right here. And that's actually a star that's getting ready to die. What happens right before it does, it flashes white hot, and so it shows up really bright in a galaxy. And then it starts pulling in matter around it. It can actually pull in other planets and stars, and it brings them about and then pulls them in all of a sudden. And that's when this explosion happens. And it's so big. I mean, it can span galaxies. That's how big it can be, and it can consume other galaxies. And then what you're left with after is what we call a supernova, and it's this big cloud of gas and dust and radiation. It's just bad and going on. Then we have black holes. Black holes are interesting because we can't actually photograph them. If we got anywhere close enough or got a telescope or a spacecraft anywhere close enough to photograph them, it would be sucked in and we'd never hear from it again. A black hole is anything but empty space. Rather, it's a great amount of matter packed into a very small area. So think of a star 10 times the size of our sun, and then try and fit it in New York City. Not good. It compacts the matter so much that it actually is said to rip a hole in time and space, and that's what happens. When we try to look at black holes or simulations of them, they look like this. We can simulate how the radiation around is twisted, but we have no idea what's in the center because all light is unable to escape it. So if light gets sucked in, sound gets sucked in, everything gets sucked in, and nothing returns. And they say that there are black holes at the center of each galaxy, and there's a supermassive black hole at the center of ours, but it's not really supported because then when we just get sucked into the black hole. But scientists think that there may be, and they think that's how the universe actually started, was out of a black hole. And then there's some theoretical scientists that are a little crazy that think every time you go through a black hole, you enter a completely different universe, which is, I don't think it's accurate at all. I think there's one universe. But we try to simulate what they could possibly look like, and we end up with these images that we'll never really know. Okay. Galaxies. A galaxy is a system consisting of stars, stellar remnants, and a mixture of gas and dust particles. Galaxies contain varying number of stars, systems, star clusters, and interstellar clouds. So galaxies contain all the nebulae, the suns. I mean, we're the Milky Way galaxy, so our solar system is like a little blip in the Milky Way galaxy. Like if we took this whole screen and pricked it with a pin, we wouldn't even get how tiny we are compared to our entire galaxy in the Milky Way. There are about 170 billion galaxies in the observable universe. That's just what we can reach with telescopes and our spacecrafts. That's how far we can see with them. So, I mean, the universe pretty much goes on forever. Oh, you can see these images. Okay. So, there are a lot of different types of galaxies, and they're basically classified by what they look like. This is the Hogg object. It's a ring galaxy, and what it basically is there's one huge star, like 50 times the size of our star in the center, and then there are little planetary systems rotating around it. So nothing can get close to that star because it wouldn't be able to exist. Some of the ring galaxies, they have asteroid belts around their sun, but mostly it's just these planetary systems circling this one giant star. It would be impossible for life to exist in these galaxies. The M87 is an elliptical galaxy. That's the kind of galaxy that we are. Usually we're viewed tilted on our side because it's an ellipse, but those usually have a bright star in the middle, not as big as a ring galaxy would, but you can actually have planetary systems close to that star. So it's about 20 to 25 times bigger than our sun, and then we would be somewhere around there in the middle rotating around this one object. M81 is a spiral galaxy. It's sometimes called the whiplash galaxy because these ends actually trail and create this kind of star dust pattern here. It's always this color, and we think that's because there's a lot of radiation in that galaxy, probably from a supernova exploding right in the middle where their sun is. But it's one of the most beautiful ones. All right, galaxy collisions. They occur when two galaxies pass directly through each other and have sufficient momentum not to merge. So they hit each other, but they don't just mix together. The stars will typically pass straight through, but the gas and dust will interact. So you have these nebulae hitting each other, and all of a sudden chemical reactions start happening. Bang, bang, boom. It's crazy. And sometimes it reforms the galaxy so it looks different. It creates the whiplash galaxies that have those tails going. That's usually what happens to them. If it doesn't happen, then they'll just pass right through each other and nothing happens. You know, maybe a few planets will collide, you get some asteroid belts rearranged, but other than that, it really doesn't happen. Cannibalism is really interesting. It's when one galaxy is bigger than another galaxy by like a lot, and so it starts to actually consume the smaller galaxy. In a case where one galaxy is much more massive than the result, than the other, the result is known as cannibalism. In this case, the larger galaxy will remain relatively undisturbed, and the smaller galaxy is torn apart. The Milky Way is actually cannibalizing two galaxies right now, and that's shown in this picture right here. There's the Sagittarius Dwarf Elliptical Galaxy and the Canis Major Dwarf Galaxy. This one right here is the Sagittarius Dwarf, and we're over here. We're right around here. So this is way out of our reach. We're never going to see this or document what exactly happened to it because it happens over such a long amount of time. It can take 50 billion years to absorb another galaxy. But what's happening is these solar systems over here are gravitationally pulling this in, and instead of absorbing what is in that galaxy, it's just ripping it apart. So it's like destroying matter. The antennae galaxies are undergoing a collision. So this was one, and this was one. And this one's actually being pulled in because it was smaller. This is the antennae M11 and the antennae M10. This one will ultimately consume this, but their shape will shift and they'll kind of merge. Last but not least, we have star clusters, or sometimes they're called star clouds. Basically, when we find areas in space where stars are packed so much together that we get images like this and this, we call it a star cluster. This is a globular star cluster, and this is an open star cluster. Globular are tight groups of hundreds of thousands of very old stars which are gravitationally bound together. So they're not going to float off anytime soon. They're all kind of circling around each other like they were their own planetary system. Open clusters, they're kind of loose. Generally, they contain fewer than 100 members, and they're really young. So before you can get one of these, you have to have one of these, and then eventually they'll all kind of pull together and rotate around each other. We have a duty to learn about what's out there in space. In order for things like nebulae to form, stars first have to die. But then out of that cloud of death, there comes life, because a new star is born. And as tragic as death is, life follows it. Out of every death, there comes a new birth, and it's the same with the whole universe, and especially with people. God gave us the universe to study and to help us understand our daily lives more. If you're ever looking up at the night sky and you're wondering what's going on up there, just remember what Job 22:12 says. Is not God in the heights of heaven? And see how lofty are the highest stars. And he put those stars up there for us to study. So I think we have a duty to do so.